Okay, so thank you everybody for being here. And I also hope that you had a nice lunch and you're ready for the next 40 minutes. And today I will try to share with you my experience in migrating a large monolith application into microservices. So to start with, who here has seen the Interstellar movie from 2014? Raise your hand. Hey, everybody. Okay. Did anybody like it? So-so. Okay. We decided that a good name for our project would be Interstellar because there were a lot of resemblance between a sci-fi movie and a migration project. We actually didn't know about all of them, but at the beginning, we knew it would be challenging, and we knew that we're not sure what we're going to do. At the end, now I know that there are a couple of other resemblances to the Interstellar project, to the Interstellar movie that our journey had. And the first one is that we ended up having a good foundation. The same as what the critics say about Interstellar movie. The good foundation is we actually ended up choosing a Kubernetes-based platform, Openshift, which actually enabled us to tackle the quality problems that we had when launching the microservices. The second resemblance I have is like the sci-fi movie. We didn't get everything right, and yeah, we had some failures. Come on. So, in the beginning, there was this majestic monolith. Not very majestic when you look at the slide. Pretty simple, but with time it grew. And it kept on growing, and it started to have all those problems any monolithic application has. And we had made good choices at the beginning. And we had created a good monolithic application 5 or 6 years ago. But then with time, it had become a small monster. So in 2017, we were approached by A1. And they came to us and said, OK, we need your help as architects to help us with our digital strategy for modernization of our software. So we sat down with them, and we looked at their top problems. The first one that was addressed to us was the problem of infrastructure. So A1 was having the issue that the current monolithic application was living on an infrastructure that was not able to scale. They were having some old physical servers. And actually, they had a lot of inconsistency between different environments. So we put that as our top priority in the list. Second, we talked with the development team that is actually responsible for the development of the current monolithic application. And one of the problems that they told us about was that they have been in a technology lock-in. So they had made good choices at the beginning of the project, but as business requirements kept on coming, they had not enough time to invest into modernization. And now they were in the situation where they were not able to adopt new technologies, and thus they were not able to use the right tooling. The business, actually, was also struggling, and this is the normal life cycle of each large monolithic application. It all starts good, and you're able to be pretty productive at the beginning of your life of your application when you start with the monolith, and this is a good choice. But as the time grows and you add more and more features to your application, you end up with a higher base complexity, and you end up with a lot of dependencies in your code. So now we were in the situation where our development team was having issues understanding the application and was not able to modify the code and release those changes. Actually, they were really reluctant to do any business changes in the current logic because that was triggering a lot of problems afterwards in production. So having that in mind, we sat down and we decided our top priority for the modernization will be to do microservices on containers and have a DevOps cycle that will help us deliver continuously for A1. So how did we do that? A couple of slides ago, I showed you that one of the problems was having the right infrastructure. So we decided to make this our top priority. And we sat down with the client, and we talked about the requirements. Our first choice was actually going for a public cloud setup, because we knew that it's working. We already had some Azure and AWS scenarios where we had been successful. But unfortunately, at the time, the client said that they have some limitations, and they need to go with a private cloud setup due to internal reasons. The second part was that as large enterprises tend to stick with certain technologies, we were in the same situation, and actually A1 wanted to have React and .NET as the software development tools to be used for their new platform, which was okay, because this way they were able to have the same technology stack in their different projects, and they already had React and .NET. So we started researching suitable solutions. We looked at 3 approaches, actually. The first approach that we wanted to do was plain vanilla Kubernetes. So we knew that this was going to work. And we sat down and we did a work breakdown structure, and we found out that it's going to take a substantial amount of time to invest into this setup, and there is a lot of challenges that will arise. So we looked at another 2 enterprise solutions. The first one on our list was Azure, and at the time in mid-2017, actually there was already an Azure Stack offering. Azure Stack is the private cloud version of Azure, and it was a good solution. But then we sat down with Microsoft, and we found out that this is a pretty new solution, and there is a lot of limitations. So comparing Azure Stack to the Azure you have right now in the public cloud, it was very limited. And also, Microsoft had gone in a certain direction where they wanted to have an all-in-one solution. So they were offering a solution which was bound to a hardware configuration, and that was putting the price up a lot. The third option was Red Hat and their OpenShift platform, which was gaining popularity at the time. We had 0 experience with OpenShift at the time, and that's why we reached out to Red Hat architects, and we sat down with them and talked about the journey that we want to have with A1. So they actually were pretty helpful. They gave us the right tools, they gave us the right learning portal, subscriptions, and everything so that we can train our DevOps team into using OpenShift, and we ended up in a very short time window able to create a proof of concept on our local environment that was running a cluster of OpenShift. So what is the OpenShift platform? The OpenShift platform is basically Kubernetes that is designed for an enterprise. So the things that this saves us is all that effort into writing all these scripts, automating our builds, and make sure that our deployed applications are working in a stable way on production. And all this is done by the Red Hat engineers. So this is saving us time, and this is allowing us to focus on our coding. So we want to code. We don't want to focus and to have our developers work in integrating that software. So that's why we chose OpenShift. OpenShift comes with several flavors. The first one is that as open source company, all the projects that Red Hat supports have a community supported edition. With OpenShift, this is the OKD, which is the OpenShift Kubernetes distribution. And this is a good approach when you want to experiment with it, when you want to set up a dev environment. You do not really want to pay for any subscriptions because you're not sure that you really need them, and you don't need support for dev. We went with the commercially supported version for production, and the commercially supported version comes with 3 different choices. There is the online version, the dedicated, and the container platform. As we had to have a private cloud setup, we went with the container platform. And the container platform allows us to run the OpenShift platform on any hardware that we want to, bare metal or virtualized. And there is several virtualization software that's there supported. And we actually ended up choosing VMware vSphere as a virtualization software, basically because we had experience, as well as the operation team on the client side had also experience. And also there is another 2 interesting options that you might find interesting for you if you have ability to go in a public cloud. The first one is the online setup. So you have prepared templates to create the whole infrastructure that OpenShift requires, and you can just pin that inside any public cloud like AWS, Google, or Azure. And then, unfortunately, you have to care about your VMs and your data. But there is also a third approach, which is the dedicated one, which is pretty interesting because in this approach, actually, Red Hat is responsible for your cluster in production, and they're managing it for you. So you can only focus on creating your containers. So we talked about the platform itself, and now it's a bit of a high-level overview of the platform. We have the 2 main components of the platform, which are the master nodes, very similar to what Kubernetes has, and the application nodes. The master nodes are the ones that are responsible for scheduling and management of our platform. And we have a nice administration console running on those master nodes that gives us the ability not only to do command line management, but also use the user interface and manage our containers. And we have the application nodes on which, exactly like in Kubernetes, our pods are running. So there is some other stuff that's different from Kubernetes in some way. We have a routing layer in OpenShift, which is responsible for exposing our services, our containers, to the outside world. So we have the ability to map them on different ports, etc., DNS addresses, and stuff like that. And we have an abstraction of the persistent storage, so we can use different types of storages that are available. We ended up selecting Gluster storage, which is a software-defined storage that was supported at the time. And also there is a service layer. And the service layer gives us the ability to have the whole platform running on an abstraction of the actual physical or virtual or cloud infrastructure. So actually this is pretty good for clients that have a journey that are about to start, and they're not really sure whether they want to do private cloud, public cloud, whether they want to migrate to the public cloud afterwards. And actually we are in the situation that we're actually thinking about moving to the public cloud now. And this is a platform that is being used both by our developers and operations. So this is a DevOps platform. So that was about the infrastructure. So a bit about how we approached the project from architectural perspective. The first one was we sat down and we thought about how we're going to do it. Are we going to do a big bang? Are we going to do a lift and shift of the old application? And which way will be the best approach with less risk and best benefits for the client? So we ended up using the kind of strangling pattern. So strangling pattern means that you're taking small bits of your monolith and extracting them as microservices in an incremental approach. This way you are making the monoliths smaller and smaller. And the best part of it is that you can actually prioritize those components, those microservices or domains that are most important for your business, and those that are going to be changed very soon. So instead of waiting for a number of years to create all those microservices, we were able from the start to actually introduce new features in the already developed microservices. But unfortunately, this is the hardest approach to do. And we ended with a lot of effort that we had to do to support it. The other principle that we were very keen on following was the stop digging principle. So it's an interesting principle, and it makes a lot of sense. We had already a very complex application, and any changes that we were doing in the monolith were triggering a lot of regressions. So we wanted to minimize them. And we also didn't want to have a lot of glue logic. So we didn't want the current monolith team to invest too much to integrate with the new platform. So that left us to a couple of limitations. We decided to do a kind of incremental approach where we would first have the business logic created in the microservice. We will not migrate the data. Then after we have all the dependencies done as microservices, we'll be able to move the data layer to the new microservice platform. And yeah, that cost us a lot of rework afterwards. Another principle that we decided to embrace was the so-called API gateway. So from a scalability point of view, this is probably not the best approach to do. But when you have an application that is very much driven by some user requirements, and there is several different user interfaces that want to communicate certain way with your applications, you end up needing such a layer. So our API gateway was the layer, which was very thin, and it was helping us do a composition of the services. So our services were domain-driven. They were actually responsible for managing the domain objects. And our API gateway was client-side driven. So it was giving us the ability to have less traffic, because now we had one request from the front end or the mobile applications, and it will compose into multiple requests to the backend services. But obviously, there was a bit of a single point of failure in our architecture and a bit of a development bottleneck, because those clients needed changes SAP inside the gateway. What did we choose as a technology stack? So I already mentioned that we had Redhat Openshift container platform as our main part of the solution. We chose .NET Core, which worked pretty well for us. React for front-end, and we decided that we want to do DB versioning on our changes so that when we do continuous integration, we can automate the whole process. So we used Flyway, which is a very lightweight solution. And it was giving us the ability to have different scripts for dev and UAT and production environments. Then we knew that we need to have messaging, because obviously there are some services which require asynchronous communication. There are certain cron jobs and services that do high load. And we looked at different solutions and decided that it makes most sense to stick with something that's already supported and integrated in the platform. So we chose the middleware that's available from Red Hat, which is the Red Hat MQ. And it worked pretty well for us. The good parts of it, it was very nicely integrated, so we didn't have much effort into making it work for production. And there was already a nice administration UI that was available for us to monitor what's happening with our queues. We needed to have a caching layer, and our practice in the .NET development was that Redis was one of the solutions that was working pretty well for us. So we embraced Redis and used it as a component for caching. So how does our architecture look like from a, let's say, dev perspective? So at first, we actually thought about implementing the logic for routing the requests between the legacy platform and the new platform inside our API gateway, and we did so. But that caused us a lot of issues with performance. So we revisited the approach and decided it's best to have a separate layer built on top of a solution that is actually a solution that's responsible for proxying and orchestrating traffic. So we created a number of Nginx containers that were responsible for sending requests either to the old platform or the new one. Then we had the API gateway, which was the only thing that we exposed to the external world. And we had our .NET microservices running in the back, connected with the MQ, the Redis, as well as connecting to the other core services inside the organization using a TIBCO. How does it all look like from an operational perspective? So one of the reasons why we chose OpenShift was that we can bring the operation to a next level. We started with our idea that we will have about 30 to 50 microservices probably in the next couple of years. And yeah, we were about that right. We're currently running 28 microservices. And we knew that we needed something that will help us better understand those microservices. So we invested into using Istio as a service mesh and Kiali for visualization of that service mesh, which worked pretty well on our dev setup. Unfortunately, when we went to production, that totally didn't work out. So we had to postpone it for production. And currently, we're still not running Istio. The main reason why this was not working was Istio was not supported in the OpenShift, and there were issues with spinning containers. So hopefully, with version 4.2, Istio is currently stable and integrated inside the platform. So we are planning to make it available for production, not just dev. Then one of the other components that was really important for us was Jaeger. Jaeger is a kind of a lightweight library that enables us to do distributed logging. So as you can imagine, inside the microservice architecture, you have one business transaction that's happening. The user clicks something, requests something, and then there is multiple calls to the API gateway from the front end to the different microservices. And they're all happening in a kind of asynchronous way. So you have the problem understanding when something fails, what component fails. And Jaeger actually gives us the ability to connect all those events into a single event that we can monitor. We also needed something to observe the behavior of our infrastructure as well as our microservices. So we used Prometheus and Grafana. They were supported in OpenShift, and it was pretty easy to integrate them with our containers. So we had sidecar containers with Prometheus, and we had Grafana, where we created our beautiful dashboards. And we also went next step, and we created some alerts that would be triggered when a certain service is down or when the platform is experiencing some issues, and that was giving us the ability to react before something breaks. What is the software development lifecycle that we implemented? So we wanted to have a DevOps cycle, so we were very keen on making sure that all the components of our solution work together and are automated together. So we had our business analysts and our team tracking the changes in the TFS, current Azure DevOps tooling. Then we had, obviously, the TFS integrated with Git, and we had our developers that were coding in their favorite IDEs and using the right tools that they wanted. We wanted to have a decent code quality, so we implemented static code analysis using SonarQube, which was also running as a container on the OpenShift platform. And next, after the changes were validated that they meet the quality criteria, we used Jenkins to start our builds. Jenkins is also one of the tools that's integrated in OpenShift. And we were able to run our builds using the different build scripts for React and Microsoft containers, using the flyway script that was giving us the ability to make the changes in the new containers, database containers. And we were executing our automated tests using SoapUI, JMeter, and NUnit for our unit tests. And obviously deploying on the different environments. So we had different pipelines that were helping us deploy and push those containers into the different environments, and then monitoring them with the tools that I already told you about. So, what were the lessons we learned from what we've done? The first part is that we were pretty much focused on the development. So we really wanted to have a very well developed and very well operated solution. And we knew that if we do it right, there will not be that much need for testing. So we didn't write very good tests, and we didn't automate enough of our tests, and we ended up having some manual work that had to be done. The second problem with that approach was that we ended up having QAs in our team, and we did not have the right number of QAs, obviously, because of resource starvation. So instead of our QAs writing test cases, they were mostly focused on executing tests. And they had to catch up with all these microservice teams that were creating new microservices, so they were falling behind. So one of the things that I think that you should do in your next project is try to make sure that your QAs are most focused on creating those tests that really check the quality of your application and make the test execution something that's the responsibility for the whole team. Obviously, QA will be part of it, but they will not be the only ones responsible. And yeah, automate as much as you can. The second thing is connected to the stop digging principle. So we're also very keen not to invest into the legacy because nobody wanted to work on it. So we didn't like it, it was old, and we didn't want to look at it anymore. And we forgot that we have to live with it for the next couple of years because we'll have the legacy running in parallel with our new microservice architecture. And that gave us a lot of issues. We actually had our first microservices trying to go live 3 times. And yeah, the third time we were successful. I think we should spend more time into looking at the legacy application. And one of the approaches that I found right now very popular actually for adopting containers is doing a lift and shift of your old application and moving it on the new container platform that you have chosen, private or public cloud, no matter what. This way, you're making the first step, which will make your operation and dev team of your current monolith application responsible for learning how the new platform works. We didn't do that, and we ended up having to support the platform on production because the current operation team was not able to do so. The third problem that we had was with the stability. So we were very keen in doing innovations. So we were not so afraid to experiment with tooling, something like Istio. At the time, Istio was totally not supported. There were not that many tutorials how to run Istio on Openshift. And we decided, well, we're going to do it ourselves. And it worked with a bit of investment. But then when we went to performance tests, we get a lot of problems on the platform. So here we decided that it's best to make sure that we are only using containers and tooling that's officially supported. Another problem that we had with stability was that when we did the initial analysis, we actually didn't do a very good job into calculating the required resources. So we ended up having enough hardware to do the VMs needed for one cluster. And having only one cluster stops you from doing any upgrades and modernization on the cluster because now you have those very small window of time, like half an hour or something after midnight, in which you can actually do work because you cannot have any downtime on production. And last problem that we had was the teamwork. So we wanted to have micro teams, and we wanted those micro teams to work in isolation. And what we created was teams that were no longer focused on delivering the whole project, but they were very focused on delivering their own piece of code. So They were focused on making sure that their microservice work, and they didn't even care that much whether this will prohibit the other micro teams into doing their work, and nobody wanted to actually be responsible for the integration. So yeah, what we did, we decided to have less teams and have those people working together more in order to make sure that they follow the same principles that are around the application. The application needs to work in production. And also, what also worked with us pretty well is we empowered our developers to be responsible for the end-to-end life cycle of those microservices. So they were no longer responsible just for dev and UAT, they were also responsible for production. So if it wasn't working on production, those guys had to fix it. So where we are right now, we are on the path of migrating to the new version of the Openshift, which is version 4.2. Hopefully, we'll get Istio on production. And also, version 4.2 will solve the major issue that 3.11 was not addressing, upgrades. Actually, I went down to Red Hat and talked with them about it, and it came out that actually none of their customers is upgrading the platform just because it's so hard. So it's a good thing that they listened to that problem that their clients had, and they invested in version 4.0, and they introduced a new containerized VMs using CoreOS, which gives us the ability to do upgrades without any downtime. So hopefully now we'll set up a new cluster and we'll migrate the current running containers and data storage from the old. The second one that we started doing ourselves on our projects is that we now knew that our platform is stable and it works. So we decided it's best to have our legacy applications lifted from their current VMs and moved to the Openshift without doing any refactoring on them. But at least this way, we're going to use one platform for all our applications. And last, we decided inside the company that we already have a pretty good knowledge with running containers on Openshift. So what we had created as templates, as continuous integration, as integrated tooling inside our environment gives us the ability to very easily start a new project without thinking about all these things. So now we actually use OCP for all our new projects, and we already have several projects that we are running on OCP. So thank you very much for your time. And
so guys, any questions for Georgi?
We have some time for questions.
Just raise your hand if you have.
Hello, thank you for the lecture. You mentioned that you were encountering some quality assurance and performance problems after the migration. Was the performance testing actually also integrated into the responsibilities of the QA members of the team? And did that responsibility shift after the teams were restructured and their responsibility were restructured as well?
The performance tests were actually done by the development team. That's the way we decided to do it because the QAs in the team didn't have much knowledge into how they do performance tests. So all the JMeter tests, the dev team did them. And the main issue was more about networking. So it became clear that we had some issues with the old legacy platform that was no longer working well when there were requests sent from the new network on which the cluster was running. And actually, as I said, we didn't invest into the legacy platform. We didn't know how the network works there. So we ended up having to create a new routing layer on ourselves, which would balance the requests between the different nodes. And we removed the load balancer that they were using before that, because for some reason that load balancer wasn't working with the network segment that we were coming from. I don't know if that answers your question.
Can you actually go back to that summary slide? If you still have the clicker.
Sorry?
Yeah. Can you go back to the summary slide? You don't have it. Anyway, when I look at that, yep,
Okay, which slide?
this one.
Yeah, all right.
When I look at that, it looks like at least half of my own career. And as a people manager, actually, how do you build a team that can deliver all of that?
The first thing I found that really works for building the team is empowering the team. I think at a certain point of time, when the team started understanding better their responsibility and understanding the product and liking it, they started to be more responsible. So they actually started organizing themselves around all the deliveries. They started taking responsibility of the deployments. And they started also thinking about all the potential problems that they're going to have later on. So that was probably one of the main things that was successful. And the other one that we did was we brought the team very close to the business at a certain point of time. And that was really helpful because they understood what the business needs to achieve, where the scalability issues are, what are the actual components that the users will be using, and which ones do make sense in the context of the business, and not just looking at some requirements written in the TFS system. And the other part that I found working was the knowledge sharing between people. So the problem that we had at the beginning was that we had those kind of silos, meaning that we had people that had specific knowledge. We had some guys from our infrastructure team that had gone through the Openshift trainings, that knew Kubernetes, and that were able to actually handle the container and operate with it, the containers and operate with them. And then we had the dev guys, which knew mostly the .NET core and how to develop their services. And then we had React guys that were pretty good in development of their React code. So we ended up combining those guys together and actually giving them tasks that they had to work together in order to execute. So I think that was one of the other things that works, and it's one of the principles of the DevOps teams. So share the knowledge and make sure that everyone can actually accomplish the task.
Mm-hmm. Thanks a lot, Georgi, once again.